Dear students, here again with the some numericals which is based on the electrostatics. While doing any numerical, what we need to know the concept and to understand the questions properly. Now if we go through these questions, we come to understand how we have to solve the numerical. Now here a question, two pith ball carrying equal charges are suspended from a common point by strings of equal lengths. Means this length is given to you, that is equal length, and this distance is given to x and the separation is given to r. In equilibrium, separation between them is r. Now the string tied at 1/3. Now this distance was x, now it is 1/3 of x and it is 2/3 of x. Okay, so tied at a 1/3 of the height from top. Now what we have to determine, we have to take the separation between them. What will be the separation when we are tying it with the 1/3 of this? Now if we go through this, here this ball is experiencing electrostatic force, that is a force of repulsion, because both the charges are equal in magnitude and of the same polarity, positive, and the separation between them is r. Now it will have some mass m and there will be a force which will be acting in this direction, that is mg, and this is a force Fe. Now if we go through this, this angle which we have taken theta. Now if we see here the force which is acting, now we'll go with this. Here these two forces, one is acting in this direction and another is acting in this direction, and we have to determine this. Now if we see here, we can have the force which is acting like this, another force which is acting like this, and this is the resultant, and this is having some angle that we are taking theta. So if we take this distance, that is given to us x, and this separation as a r by 2. So it will give you the tan theta. Tan theta will be equal to this perpendicular and base, it is r upon 2 upon x. So we can have this relation for tan theta. Now if we go through the force Fe which is acting in this direction and the force which is acting in this direction. Okay, so here we will have these two forces, their resultant which we can determine, means the total force which is acting, this will be given by Fe which is equal to mg tan theta. Now why we have taken Fe which is equal to mg tan theta? If we take this, it is this angle and this angle, both angle will be same. This is mg, and if we take this, so it will be Fe. So Fe which is equal to mg tan theta, we can say Fe upon mg which is equal to tan theta. Now Fe will be given by this mg tan theta, means mg into r upon 2x. Now if we go through now it is tied with this, again we are having the distance which is changed now 2 upon 3x. Now here we are assuming tan theta dash which will be given by this distance will be r1 upon 2, and this is your 2 upon 3 into x. So tan theta will be given by, tan theta dash will be given by 3 r1 upon x 4 tan theta 1. And similar, the force which will be acting here, we are taking this as an equation 1. Now the force, again we can have the same resultant Fe dash which will be given by mg into tan theta dash. Okay. Now tan theta dash, that we can substitute here, mg into tan theta dash, that is 3 upon 4 r1 upon x f e dash. This is equation number 2. Now if we take the ratios of these two, fe upon fe dash, which will be given by mg into r upon 2x, and this is again mg 3 times r1 upon 4x. Okay. Now these values will cancel, mg, mg, and this x, and it is 2 times. So fe upon fe dash will be given by, this is r, this is r1 multiplied with this, and 2 upon 3rd r upon r1. This relation which we have got. Okay. Now if we go with the electrostatic force which is acting here, so electric force will be given by k times q into q upon this distance, that is r square. Similarly here the electrostatic force which is acting, this will be given by fe dash k times q square upon r1 square. Now we can take these two forces, it will be also k times q square upon r square. So we are substituting it here, k q square upon r square upon k times q square upon r1 square, which will be, it is in this ratio, so it is 2r upon 3r1. Now see here, this is also cancelled. Now it is r1 square upon r square, which is equal to 2 upon 3 r upon r1. I will multiply it with this r1 cube, and in denominator we can have this 2 upon 3 r cube. Now the r which we have to determine, now the by strings of equal, now the strings tied at 1/3 of the height from this. Now we have to determine this r1. So if we go through it, r1 will be equal to 3 upon 2, we can take it as 1.5 in denominator, and it is r cube. Now the new separation that we are going to have, r1, which is equal to, it is yes, the new separation which we are having, it is r under root 1.5 cube, r cube root of 1.5. 3/2 we have done it, 2/3 instead of writing 2/3 we have written it 3/2. It is 1.5. So r1 cube is equal to r cube 1.5, removing r cube root, it will become a cube root. It is r upon cube of root 1.5. So now if we go through the option, this option will be correct. So here we have the answer, and we have determined it with the help of very small this, because the force which is acting because of the gravity that we have taken it having into G. This is the electrostatic force which is acting in this direction. Now we have taken it as a resultant. One force is acting in this direction, one force is acting in this direction. So if we take this, this is Fe and this is mg. This will give the resultant, and if you know the angle of this, it is a theta. So tan theta, this is Fe, this is mg, perpendicular upon base. So that's why we have taken Fe is equal to mg into tan theta, the force which is acting, electrostatic force here. And after separation we have got this same we have applied here, and we have got the final answer. So by doing in such a manner, we can solve the numericals and ultimately we can solve the MCQs if we know the concept. So go through these questions. We are heading with some numericals which are based on the electrostatics. In coming days we will go with the other topics also. So be in touch, join it and subscribe it also and share it with others also. So you get lot of benefits